All right, I'm going to start up. Today is Tuesday, the 20th of September. And the first thing I'd like to do, and hopefully you can see this on your screen right now, is the email that I sent out, about an hour ago. And as it says, today we're going to be going over Chapter 8, which is on arrays and collections. This probably, from what we've covered thus far, is the most complex chapter. It's definitely not the most complex chapter in the book, but it's got a lot of stuff in it that we're going to use in many ways from now on. All right. And the reason I'm telling you that is we went over 3 chapters, then we had a test. Then we went over 2 chapters and we had a test. Then we went over 2 more chapters and then we had a test. Well, the next test that we take, which will be next week sometime, will be just on chapter 8. All right, because there's enough material in there and enough new stuff. So today I'm going to go over chapter 8. All right. And that's all I'm going to do. I'm not going to go any further than that. I'll probably give a couple simple examples, etc., as we go. But rather than get too heavily into it, that's what I want to do today. And if you have not had a chance to look over chapter 8 in the book, I would very much appreciate it if you do it by tomorrow. Tomorrow, what I'm going to start with is I've written some of my own applications for arrays. In fact, one of them is very similar to one of the problems that you are asked to do for chapter 8. I don't care. And we're going to look at a couple of these examples and we're going to look at them both. I'm going to do one first as a console, maybe even a couple, we'll see. And then we'll go and turn it into a GUI. And it'll have a chance to show you a lot of different things about arrays. And there's a few, collections which are discussed in here also. All right. When we get done with that tomorrow, I don't know how long that'll take. Then we're going to go over what's going to be due for chapter 8. So in other words, I don't go over the written tests because I think they just make sense, but we will go over the labs that are due and the homework that will be due. One thing to note, there will be no homework due this weekend. All right. I just figured that we're getting into this and I wanted to make sure you had enough time to hopefully develop a comfort level with it. So again, tomorrow, Wednesday, we'll go over some array examples. Thursday, there'll be more array examples and I'll go over 1 or 2 as I have been doing from the homework and from the labs. All right. Then Friday will be lab for the entire period. You are probably going to get at least an hour of lab, I'm going to guess, in probably most every day that for the rest of the week, at least Tuesday, Wednesday, and Thursday. Again, Friday will be lab the entire period. When you come in on Monday, in fact, I will email this out to you on Friday, will be the pretest for chapter 8. And it won't be, I believe at least when I wrote it, that it's brand new. So it's not like you're going to be adding on to the last pretest that we did. You're going to be doing something totally new. So that'll be Monday. And as always, I'll give it to you on Friday and I'll give you the first hour and a half on Monday to work on it. And then starting at 9:30 on Monday, I will go over the pretest. Then on Tuesday, so 1 week from today on the 27th, you can plan on there being the next hands-on test 4. Again, as it says on the bottom there, the chapter 8 written test, the chapter 8 labs, and the chapter 8 homework will not be due until a week from Sunday. So not this Sunday, which I believe is like the 25th or whatever it is. All right, 24th, I guess, I don't know, but it'll be due the 2nd. All right. Okay. So with all that stuff more or less in mind, let's get into the textbook. So let me come in here and let me change my share. Go back to the internet. And am I right in assuming that you can see on your screen right now the index page from our Murach text?
Yes.
Okay. So you know this. We've already gone over 1 through 3. That's done. We've gone over 4, 5, and 6, and 7. Now we're going over 8. Let me just tell you real quickly that next week, after we take the test, so you could plan on Wednesday, Thursday, and Friday of next week. All right. Not Friday, but Wednesday and Thursday, we're going to go over 3 chapters in a row next. So we're going to do 9, then 10, then 11. Now, the good news is when you have your test, there'll be virtually nothing on it from chapter 11. It just shows you some more advanced debugging options that you'll be able to use when you're working on your test. So really, the heart of the next test after this one will be 9 and 10. All right. Now, what that means is not by the end of this week, not even by the end of the next week, but by sometime in the following week, we're like in chapter 7 or something like that. I don't know, or week 7, I should say. We're half done with a book. Then we're going to slow it way down. All right. And we're going to spend quite a bit of time on this section right here. But we're only going to cover some of the stuff that's in here because a lot of it is so doggone complex that I've got a feeling I could very easily lose you. So even though I may lecture on each one of these chapters, you'll have a test probably just on chapter 12, and then another one on 14 and 16 is what I'm looking at right now. All right. Then we'll go into section 4, chapter 17 and 18, and that'll almost seem like a break after going through the object-oriented stuff. But especially chapter 18, link, don't worry about what that means right now. But it's a very good prelude or opening or introduction to what we'll do towards the end of the class, which is working on databases. Just so, again, you have some kind of an idea where we are, where we're going, etc. So let's jump into chapter 8. So I'm on page 223. All right. Now, kind of an important point here, when you look at it right from the start, arrays and collections are objects that act as containers. All right. What we've basically been working with almost exclusively thus far are what are known as either simple data items. They're also known as scalar, S-C-A-L-A-R data items. In other words, each variable that we've created thus far holds one thing. All right. When you come in and start using arrays and collections, what you have is one variable that can hold many things. All right. And my guess is that, and I could be wrong here, but my guess is that none of you in this class have yet taken the AWD1000 class, all right, which is the Web Development Technologies class. The reason I bring this up is, if you have any experience with arrays in JavaScript, arrays in JavaScript are unbelievably liberal. In other words, they allow you to combine different data types in the same array. All right. C# does not let you do that. C# is very conservative. So when you create an array and you say that it's an integer array, then the only thing that it can hold are whole numbers. If you create an array of Booleans, then all it can hold are things that are true and false, etc. All right, so we're going to start, and most of the chapter, when you notice in here 224 to 250, so the first 25 or so pages are on arrays. Then in the last 15 pages, we talk about lists. We will talk about lists. You may even have a homework assignment on lists, but I'll have to check this. I believe that your entire pre-test and your next test are only on arrays. I could be wrong, and I'll try to check that by tomorrow. All right, so one-dimensional arrays, rectangular arrays, jagged arrays, skills for working with arrays, and then finally working with collections. And you'll notice the last collection that we'll talk about are array lists, so they're a special type of array. All right. As always, my hope is that if you have questions, you're going to ask. All right. So before I go into this, which I'm going to do just in about a minute or two, but before we do this, I want to stop my share and restart my share. And I want to show you something that right now, as you look at it, may make absolutely no sense, but it's okay. All right. Okay. I have been living in Missouri now for, I don't know, about 6.5 years. All right. When I moved here to Missouri, my wife did not move here. All right. We had a house in Rockton, Illinois, and we had a daughter at the time that was going to school and she was living with us. So while she finished up her education, my wife stayed at our house in Illinois and I got an apartment. And that's what I'm trying to simulate right here. Now, I only made it a 6-unit apartment. The one I lived in was an 8-unit, but it really doesn't matter. Okay? The point is this. You can, as you can imagine when you look right here, and I was in apartment 1, all right, and I don't have any idea. I never really met any of my neighbors, but if it was a 6-unit, it'd be apartment 1, apartment 2, etc. You get the idea. So if somebody were to send me a mail that would say Jeff Scott, and let's just say it was 123 Main Street, it wasn't, in Wentzville, Missouri, 63385. All right. Well, what would happen? The postman, or postwoman, it doesn't matter, would come. And if you've ever seen the way that it's set up as an apartment, typically there's like a big key that they can put in there and they can open it up and see, in this case, all 6 mail slots. All right. And the guy would look and he'd say, oh, it says Scott. Oh, Scott must be apartment 1. All right. So he'd put it in there. Now, if the person really wanted to make sure I got it, they could say something like apartment number 1. All right. But what if they did this? All right. If they did that, I might still get it, or it might go to Brown. All right. Again, why am I telling you this? Well, the house that I live in a house in Lake St. Louis, Missouri. And before I bought the house, it was a rental property. The reason I'm telling you that is I still get mail. We've been in the house for over almost 4.5 years, and I still get regular mail, USPS mail, to people who used to live here. All right. So if somebody just sends something to somebody, in other words, if they send something to apartment 1 and they put in here, I don't know, John Clark, apartment 1, there's probably a pretty good chance that I'm going to get that mail anyway. All right. Now, the way it used to work when I was there, all right, if somebody did this, if they said John Clark like this, and the postman looked and there was no one there by that name, there was like a little ledge that was on top of the mailboxes. And literally what the post person would do would be to leave that kind of email on the ledge because they wouldn't know what apartment it went into. So what the heck does this have to do with arrays or anything else? Actually, a lot. All right. And you'll notice I reproduced this down here. Why? Well, when we start talking about arrays, the first thing is we don't start with 1, we start with 0. Now, that wouldn't make much sense to say somebody is living in apartment 0, but I'm just trying to have you understand what's going on here. Okay? So if I came through here and I wanted to go and create an array of strings to hold all the people that are in this apartment, I would do it like this. I would come in there and I would say string, bracket, bracket, and I'd say tenants, let's say, equals, and then I could come in here. I could put all this on one line, but I'm going to put it on multiple lines just so you can see it on multiple lines. I don't have to do that. All right, so I could come in here and I could say, Scott, Brown, Green, Jones, Smith, and king. All right, just like that. And since I am creating a new variable here, I need to put a semicolon there. All right. So what that's basically doing is it's saying I'm creating something called tenants, and the 0th tenant will be Scott, the 1 tenant will be Brown, the 2 will be Green, the 3 will be Jones, the 4 will be King, and Smith rather, and the 5 will be King. Now, if I had wanted to do this, I could literally have just put all this on one line, or I could have put it, 3 on a line and put it on 2 lines. You get the idea, hopefully. All right, but I could do this any way that I wanted to do it. All right, it's very much not limited as far as the way this is set up. So you'd probably more often see it looking something like this. It's a little easier to read. Okay. Now, what if it was a brand new apartment complex? All right, so what if it was brand new? In other words, there's nobody who lives in it yet. All right. I cannot do this. I can't do that. The system doesn't know what I'm doing, but I want this to be an array. All right. So I can come in here and do something like this. Let me hit enter here. I can come in there and say new string, and then I have to give it a size, 6. Then later on, as people start moving in, all right, I could come in there and say tenants 0 equals Scott. I guess it's tenants. Let me just grab all this. So tenants 1 equal Brown. Tenants 2 equal Green. Tenants 3 equal Jones. You get the idea. Tenants 4 is going to be Smith. And finally, tenants 5 is going to be King. Now, even though when we created this array right here, we said it has 6 elements, the first array element is always array element 0. There's an old joke, and it isn't funny, but there's an old joke: ask a programmer to count to 10, and she or he will say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Because like many things in computers, when you work with arrays, the first element is not element 1, right? It's actually element 0. Okay. Now, again, should you care? Well, think about this. What if I was creating another array? So what if I came in here and I said string bracket, and I put in here months equal, and I'm not going to write them all in, but I'll just do January. Dot. I'm not going to write the rest, but hopefully you understand what I'm saying. The problem is now month 0 is January, month 1 is February, etc., which is a pain. So what I can do is I can just put a placeholder in here that says basically there is no month 0. And now month 1 will be January, etc. All right. So what I'm trying to get across to you with this example is, okay, I can either create an array like I showed you before, and I guess I shouldn't have removed it, where if I know the values ahead of time, all right, if I know the values ahead of time, I can just fill the array up with those values from the get-go by putting them inside of curly braces. But a lot of times they're more like what you see here. You won't know the values ahead of time. So if I come in here and I put in dot, oops, try that again. Dot, dot. All that means is there is some processing that happens in here. I don't know what it is. I don't care what it is. All right. But again, near where I live, especially when you go down, what is it, 364, they're putting up apartments all over the place. All right. So again, imagine that they had a brand new 6-tenant unit that they hadn't yet leased. All right. So what I'm trying to get across to you is when you create these, okay, you can either, basically, this is going to set it up to an array that has 6 strings in there, and they all have the empty string. In other words, there's no value in any of them. What if I came in here and did this? If I said int, bracket, bracket, and I said in here test scores equal, and we'll say new int, and let's just say there's 20 people in the class. All right. Now, automatically, each one of those 20 slots, so to speak, 0 through 19, will automatically have a value of 0 in it. If I went in and created a Boolean, all right, I don't know. So, well, let's just call it is married. And let's just say for all 20 of you, I'd say new bool 20. All right. If I don't initialize them, they're all initialized to false. So when you create a new array like this, what you'll find is strings automatically, each element will get the empty set. Anything numeric will automatically get the value of 0. Anything Boolean will automatically get the value of false. You'll see that a little later in the book, but I just thought I would show it to you right there. All right. We're going to, in a little bit, we're going to take a look at the Microsoft documentation for arrays. And one of the things that you'll notice is arrays have a thing called length, and it's a property. So in other words, if I said, what is the length of tenants? It would return 6. All it cares about is the number. All right. And why is that important? It's important because, as you'll see in just a few minutes, arrays work unbelievably well with for loops. For loops are really counting loops. And when you're working with an array, you know how big the array is. All right. Now, there's one more thing I want to say, and then we're going back to the book. All right. And I want to just very quickly talk about a couple terms with you. All right. And they are what are referred to as early binding and late binding. All right. When you work with a language like JavaScript, no, not C#, when you work with a language like JavaScript, what you are able to do when you work with arrays is, as the program is running, you are able to make the array larger or smaller. You can change the size by adding things to an array or removing things from an array. And the reason I'm bringing that up is that's JavaScript, and the size is set at runtime. In other words, as the program is running, you are able to literally change the size of things. All right. Now, C#, Java, and many, many, many other programming languages use what's called early binding, and that is set at compile time. And it's really important that you understand that. What do I mean? I could not add a 7th tenant in here. I can't make it any bigger than 6. 0, 1, 2, 3, 4, and 5, because the size is set at compile time. So once the program runs, you can't change the size of an array. All right. In C#, in Java, and in most programming languages. JavaScript and PHP is another one. They're a little bit different animals. They're late binded, so you can make arrays larger and smaller in those two languages. All right. Okay. I'm not even going to ask. Hopefully that at least made a little bit of sense going over it with you. Okay, so I want to jump back into the book then. So let me change my share back to our textbook. So some of the stuff that's in here, you'll have already seen, just so you know. As it says, you can use an array to store a set of related data. All right. In fact, whereas what we've been working on so far, I already told you there's simple data types, or sometimes they're called scalar data types. All right. They're also referred to sometimes as elementary data items because they're as simple as it gets. What we're getting into now with the array is the first time we're talking about what's referred to as a data structure. All right. And if you remember, I think I gave you an example a while ago, and hopefully I did at least, of, you walking into a classroom in the first day, and there's maybe 20, 30 of you in there, and there's no instructor. And you wait for 5 minutes and there's still no instructor. Then somebody walks in saying, hey, the instructor is going to be a little late. Here's a Lego for you to play with. All right. Well, those Legos that's what we've been working with thus far. They have been scalar or elementary data items. You putting your Lego together with the person next to you and the person behind you and the person behind her and the person behind him, etc. That's creating a data structure. So that's what we're doing right now. So when they say to store a set of related data, that's what they mean. And the first type that we're going to talk about, the type I just showed you, is what's called a single dimension array. You can have arrays in as many dimensions as you need. But let's start with just talking about the single dimension array. All right, so the syntax will be shown on the next page. I've already mentioned it to you. Each thing that's in an array is called typically an array element. So in other words, in the example that I just showed you, and I'm not going to go back to it, but array element 0 held Scott, for example. All right. Again, as it says here, when you create an array, each element is initialized by default. To what? It depends on the type of the array. As I already mentioned, numeric types all are set to 0, not just an int like I showed you, a double, a decimal, etc. So we'll look at that in just a couple minutes when we look at the table. It says in most cases, all of the elements in the array will contain the same type of data. In almost all cases. In fact, all that I can think of. All right. It says if you don't know what type of data an array will contain, you can declare it with the object data type. We're not going to worry about that one for now. All right. So when you look in here, these are kind of examples of what I just showed you. You can either, like we did with regular variables, this is declaring the array. This is initializing the array. This is doing it in one statement. Why would you want to do it in one statement versus two statements? What if I wanted to write myself a program and I wanted to be able to use, let's say I have 3 classes. One class has 100 students, one has 50 students, and one has 10. Then I might ask, okay, how I might declare an array like this. So I might say, int bracket students, something like that. Then I might come in and say, well, how many students are in this class? All right, 10. Then I could say students equal new int 10. But if you said how many are in this class, 50, it would be the same thing, but instead of putting in 10, I'd put in 50, etc. If I know all that always ahead of time, I'm just as well off doing it like this. So again, here's a couple examples. The first one, again, declares it in one statement, initializes it in the other. The second one does both the declaration and the initialization together. All right. Any data type that we have discussed thus far, in other words, what have we worked with thus far? We've worked with ints. We've worked with decimals. We've looked a little bit at doubles. We've worked with Booleans. We've worked with strings. Those have been the 5 types that we've used most often. You can make an array of any of those types. And as I already mentioned to you again, we haven't really done much with date and time, but you declare a numeric array. If you don't give everything in the array a value, it automatically is 0 initialized. All right. Strings are all going to be basically the null string. Booleans will all be false, etc. So an array can store what are referred to as one or more elements. The length of the array, also known as the size of the array, is how many elements are in it. If I say there's 10, those elements are numbered 0 through 9, but there are still 10 elements. All right. All right, how to assign values to the elements of an array. And that's kind of what I showed you, where I did something like this with the example that I just showed you of me in the apartment. And I said, if it was a brand new unit coming in and saying string bracket bracket tenants equals new string of size 6, and then we fill them up. So sometimes you don't know the values that are going to be in the array ahead of time. Or sometimes, it might be as the program runs. I mean, think about this. If I had an array like they're showing here, all right? But let's say that instead of calling it decimal totals, we called it decimal months. And it's going to be a decimal, even though it's called months. And it was going to have size of 13, 0 to 12. And in total, months 0, we're not going to put anything, as I mentioned before. But these might be my January sales, my February sales, my March sales, and I might fill those values in at the end of each month. All right, so I may not even know them as the program's running, if I've got a program that is continuously running. All right, so there is an example of going and assigning values to a decimal array, another one in assigning values to a string array. Now, this is important. This line right there is really important. It says totals 4 equals 8.95 M. What you're trying to do is you're trying to store a value outside of the boundaries of the array. If you do that, what happens is what's referred to as an index out of range exception is thrown. So what we're saying here is we have 4 values: totals 0, totals 1, totals 2, and totals 3. If I try to put a number in after totals in the brackets that's either less than 0 or is greater than 3, I'm going to get one of these index out of range exceptions. And that's another thing, because we learned that in our last chapter. This is another thing that we can use a try catch on. Now, when you do this and you initialize an array, I use the middle way that you see right here. Or actually, we use the bottom way here. You can do it like this. I have never in my life seen anybody do it that way: decimal bracket bracket totals equal new decimal 4, and then put that in. But what's important here, this is what I want to stress, is if you do it like this, right there, do not put a number in here. All right? Do not put a number in these 2 examples. You let the system figure out, oh, there are 1, 2, 3 elements in the names array. There are 1, 2, 3, 4 elements in the totals array. All right? And it says you can even create an array whose type is inferred from its values. So this would be inferred that these are integer. I don't think that's good programming practice. I think doing it the second or third way that you saw up above is the right way to do it. All right. Then the description here, as it says, when you refer to the elements in the array, each one of these things that you see in here in the brackets is referred to as an index or a subscript. you will typically see this read as names sub 0 equal Ted Lewis, names sub 1 equals Sue Jones, names sub 2 equals Ray Thomas, etc. So as it says here, the index of the last element is known as the upper bound of the array. All right, most of the other stuff that's in here, I think we've already talked about. All right, working with arrays. So here's going to be a couple of examples. All right, I already mentioned this to you, and I guess the length should have been a capital L, all right, from what I showed you before, but that's okay. That's the size of the array. That's not what the values are in the array. It's how many actual elements there are in the array. All right, so they've got a thing there with totals, and there's absolutely nothing wrong with what they show here. All right, so they've got 4 totals. You can see what they are, 4 decimal totals. Then they add them up. So total 0 is 14.95. Totals 1 is 12.95. Totals 2 is 11.95. And totals 3 is 9.95. You add those up, you put them in a sum. Let's just say that the total in there, I don't know what it is. Let's say it's 48. And then you take that 48 and divide it by 4, and that becomes your average. Now, there's nothing wrong with doing it that way, but you're almost always going to use some kind of a loop to do this. All right, you're going to see examples more so after at least after the first break. But if you look at the second example there, this is writing a for loop, and this is where it gets confusing. I will tell you, when I first learned arrays, this drove me batty, seriously. I couldn't understand what this was supposed to be. And if you get it, and if you get it faster than I do, good for you, really. This I that's in here, that I that you see right here, where I've got the mouse going, or the cursor going up and down, that's a placeholder. So we're running through this loop 10 times, from 0 through 9. So the first time we run through it, numbers I, that I will be a 0. So we set 0 equal to 0. This is literally saying set 0 equal to the first location, 1 equal to the second location, 2 equal to the third location, etc. The other thing that's new in here is notice in the for loop, notice our test, I less than numbers dot length. When you are working with arrays, you should always use the length property. And what I mean is, rather than saying I less than 10, you say, well, could I have used I less than 10? Yes. But later, if they change the size of this array from 10, let's say, to 25, and you do it like this, you don't have to change your size. But if you manually put a number in there, you've got to remember to change that number. And you may say, well, that's not a big thing. I'm just telling you that the way that most people do it, all right, is the way that it's shown here. Okay, then they run through the loop and they loop through the array again and just print out all the different numbers that are in there. Okay. There are some really good examples in here. This next one that's now near the top of the page here on page 229 shows how you can loop through an array and you can get both the sum of everything that's in the array and then when you're done, the average. All right, and then they display it. We're going to look at a lot of things that are going to be similar, not identical, but similar to this tomorrow. All right. All right, now I'm going to show you something, and whether it's good, bad, indifferent, or something else, it's the way it is. Everything we learned about for loops so far, you can use with arrays. Everything. But there's other kinds of for loops that you can use, and many of them are special in that they are to be used with arrays. One is the for each loop. And rather than read this stuff to you, which I think it'd be a waste of both our times. Let's go look at the examples. There's the syntax, but let's look at a real example. All right. So it says here, string number string equals the empty string. For each int number in numbers, all right, what are we doing? I don't even care what this is. I don't care about this. This is just basically printing out, showing you this, and then printing it out. What's new is this, right? Well, there. Int number in numbers, because people get confused. What is that? Number is a variable we're making up on the fly. Most people pluralize their array names and then use the singular version in a for each loop. So int number in numbers. So again, numbers is the array. Number is one of the elements that's in the array. It doesn't have to be called that. You know, you could have said int hello in numbers, and then you just would have replaced the word number there with hello, and it would have worked just fine. But a kind of common practice is to do it this way. Now, why would you use this for each as opposed to a regular for loop? Remember, when we have a regular for loop, you have to initialize the for loop, then you have to test the for loop, then you have to increment or decrement the for loop. Well, all that stuff is done automatically for you with a for each. All right. And I've had people who've said to me before, you know, I really get the for loop. Okay, I get it. It makes more sense to me than the for each. Can I keep using it? Yes. All right. But this is just going to save you a few keystrokes. So on the last page, we looked at how you can compute the sum and the average right there. All right, then they come back over here and they've done this running total. So these are the 9 numbers. Then they add the 9 numbers up. All right. In fact, they use these things. These 4 numbers here. 14.5, or I'm sorry, 14.95, 12.95, 11.95, and 9.95. So they use those 4 numbers. They add them up and put them into sum. Then they divide them by 4 to get the average. And there they are. So there's the 4 numbers. There's the sum of the 4 numbers. There's the average of the 4 numbers. So as it says here on the bottom of page 231, you can use a for each loop to access each element of an array. You can also use it for collections that we'll talk about later on. All right. So the first, those were one-dimensional arrays. Those were simple arrays. Let's at least start to get into this. And I'm going to give you a break, but I'm going to wait until 9 o'clock and then we'll take a 10-minute break, okay? The next type are rectangular arrays. Now, I am not asking here. So I am not asking you what I'm about to say, okay? And I don't want to put you or anybody else on the spot. But I just want to show you something quickly. So I'm going to change my share for just a second. And just tell you that most people that I know at one time or another have seen a spreadsheet. That's what you should see on your screen right now. All right. And these are rows and these are columns. So this is, so in other words, let's just say that I had 5 names. I would have 5, 1, 2, 3, 4, 5 rows. And from what we've heard, this would be row 0, row 1, row 2, row 3, and row 4. I would also have 2 columns. This would be column 0, this would be column 1. You can always tell how many elements you have in an array like this, a two-dimensional array, because you multiply the rows by the columns. When you create an array like this, it's always recommended that you do it in row column order, not in column row order. If you say, I don't know what you mean, you're going to see it in just a moment. The reason I showed you this, though, is I have literally had discussions with people where they've said to me, I just don't get arrays. All right. And especially these two-dimensional arrays, they make no sense. And I asked them, have you ever worked with a spreadsheet? Yeah, I work with them all the time. Well, guess what? You're working with a two-dimensional array. The only difference is if you use Excel, this cell right here is known as C, so it's column C. It's known as C9 right there. It's column C, row 9. All right, if we were using this, it would be 0, 1, 2, 3, 4, 5, 6, 7. It would be row 8, 0, 1, 2, column 2, the way that we would look at it. All right. Now, is that big a thing? No. And you can have arrays of as many dimensions as you want to or need to have. Now, most arrays that you see are either going to be one-dimensional or two-dimensional. I have worked on occasion using three-dimensional arrays, but it's very hard for people typically to work with an array of more dimensions than 3, because if you can't imagine it pictorially, typically it's very hard for you to write it. All right, plus if you have too many dimensions, it can start to get a little bit confusing, period. All right, so let me jump back. All right. So again, the next thing is rectangular arrays, also known as two-dimensional arrays. When you create a rectangular array, as you'd probably guess, the syntax will be a little bit different. All right, and again, as you create it, you can assign values to it. Okay, we're going to look at those right now. So here is a two-dimensional array. All right, now, fortunately or unfortunately, you know, the kind of the examples they give are a little hard to understand, but they've got here int, then notice what they have in the brackets, just a comma. All right, and then we've got numbers equals new int 3, 2. What does that mean? Well, the first thing that should kind of just make sense to you is there are 6 elements in the array, because 3 times 2 is 6. All right, and there are 3 rows and there are 2 columns. Now, I wish they had drawn the picture for this like they did for this one, but they didn't. So imagine instead of this saying 3, 2, imagine this said 4, 4. So you'd have 16 elements, and there they are. So the first row would be row 0, column 1, then row 0, column 2, really row 0, column 0, I should say. Row 0, column 0, row 0, column 1, row 0, column 2, row 0, column 3. All right, then we repeat the process, but with row 1. And you'll notice that when you assign values to them, since it's two-dimensional, you need both a row and a column. You can, when you create an array like this, it's totally legit. If you know the values, you can assign them at the same time. Notice the way that this is done in the example near the top here of page 233. And that is, you've got curly braces within curly braces. Totally legit. So here they have a 3 by 2. So there's row 1, row 0, column 0, row 0, column 1, row 0, column 2, etc. So a rectangular array, as it says, uses 2 indexes. Very much, again, like what we saw in the spreadsheet, it's a table with rows and columns. All right. Now it says, although it's rarely necessary, you can extend this two-dimensional syntax to work with arrays that have more than 2 dimensions. Yeah. So when we start working here with rectangular arrays, all right, some of it looks a little bit weird, for lack of better words. The key takeaway from right here is what you see almost smack dab in the middle of the screen. All right. And what I mean is that example right there, since there's 2 elements in the array, all right, we've got 2 loops. The first row that you see right here, that's going through the rows. The one that's inside is going through the columns. So 2 things about this. First of all, you need a differently named loop control variable. In the first case, for rows, our loop control variable is named I. In the second case, in columns, our loop control variable is named J. They have to be different. You can't use the same name for both. All right, if we had a 3-dimensional array, we'd have yet another one. All right. After the break, I'm going to show you, it's not going to be arrays, but I want to show you this idea. All right. And I want it to hopefully totally make sense to you. Now they talk about this get length. I don't know how often I even use that, but it says you can get the number of rows or the number of columns in a rectangular array. All right, but the key takeaway is what I said before. You use nested loops to iterate through the rows and the columns of a rectangular array. All right. Okay, it is 8:58. Let's take a break right now, please, and we'll come back at 9:10. I got to leave for a couple minutes. I have no water and I'm very thirsty. So I'll be back in just a couple minutes and we'll pick it up on here on page 236. All right, let's continue on then by talking about jagged arrays. And key thing is that first sentence there. Jagged arrays let you store data in a table that can have rows of unequal lengths. All right. It's also known, as it says, as an array of arrays. Now, when you look here, what you'll notice is it says to create a jagged array, there's the syntax. All right. Now, when we do this, we're saying that this array has 3 rows in it. All right. But it's a 2-dimensional array. So there'll be numbers 0, numbers 1, and numbers 2. So there's 3 of them. And notice that the first one has got 3 elements. The second one has got 4 elements. And the third one has 2 elements. Well, think about this. Forget about computers for a second and think about how you might want to use something like this. What if we had a list of families? All right. So what if this said int bracket bracket families equals new int, and maybe we had 20 of these. I don't know. So we have families 0 through families 19. And what we wanted to do in here was, instead of an integer array, we wanted to be a string array. And we wanted to have how many members were in that family. Some people might have no kids, so there might just be 2 members of the family. Some might be a single parent, and it'd be 1. Some might have many kids. So if we were doing something like that, anytime that you are working with something where you can at least possibly have different numbers, that's when a jagged array comes in well. Think about this otherwise. Let's look at what they've got right here. Look at their example. All right. Imagine that what these represented, these 3, 4, and 2, were periods in a year. So let's say that every 3 months, so quarters of the year. So January, February, March would be quarter 1, etc. All right. Well, let's suppose that this is a person, and that person here, in the middle, they got hired in at the beginning of the year. So they would have number figures for quarter 0, which would be the first quarter, for quarter 1, which would be the second quarter, for quarter 2, which would be the third quarter, for quarter 3, which would be the fourth quarter. Now imagine this person wasn't hired in until April. So they missed quarter 1. So they would only have sales for the second quarter, the third quarter, and the fourth quarter. And then finally, imagine that this person was hired in July. So they missed the first quarter and they missed the second quarter. So they would only have sales for quarter 3 and for quarter 4. Not the greatest of analogies, probably, but all I'm trying to get across to you is, with a jagged array, you can have a different number of columns. Now, I know a lot of people who will tell you, hey, avoid these things like the plague. It depends on what you're doing and what your requirements are. All right. What we could have done here in this example that you see right here, where we've got titles, we could have just literally put in there bracket, bracket titles, and we could have set all of them equal to having, I don't know, the same number of rows and the same number of columns. But here we'd have 3 columns in the row. Here we'd have 4 columns in the row. And here we'd have 2 columns in the row. In other words, we'd be wasting 1 column here, and we'd be wasting 2 columns here. Now, a lot of times that, you might say, well, who cares? And if you don't care, then you could do it that way. So as it says there, you use jagged arrays to store data in a table that has rows of an equal length. If you don't assign values to the elements when you declare them, The declaration statement must specify the number of rows because it has to know how big to make it. Right? I don't think we're going to probably deal too much with jagged arrays, but like I said, they have their place. And in this example right here, what do we have? We've got 3 different number strings. The first one has 3 numbers in it. The second one has 4 numbers in it. The third one has 2 numbers in it. And you can see, all right, so we have 3 rows, but the number of columns varies in each row. So where this is varying is going to be in our inner loop, because the outside loop is handling the rows, the inside loop is handling the columns. So as it says here on the bottom of page 239, since the number of columns in each row varies, you can't use the get length. All right, because you're going to have a different number in each one. So they didn't use get length, they used length there. Get length supposes that every one is the same thing. Every column is the same length. All right, page 240, more skills working with arrays. Well, hopefully you can see this and what I'm about to do, and if you can't, you're going to have to tell me. But I'm going to go out here to the internet, and I'm just going to type in C# array methods and hit enter. And ideally, one of the first things that comes up is our documentation from Microsoft. And when I go out there, yeah, it's got a whole boatload of examples, but there's properties that arrays have. But let's go down to here. One is that length property that we already talked about. But we've got methods. All right. There are things that you can do with arrays. Tomorrow we will look at, for example, a binary search. Give you my very quick little example of a binary search. If you heard it before already, I apologize. All right. A couple of years ago, I was on vacation in summer, and I had nothing better to do that day, and I was watching The Price is Right. All right. And the person who was up on the stage had to guess the price of a refrigerator. And they said $700. And the host said higher. And they said 701. And I thought, you're not going to win, because they had 60 seconds to guess the price. So what do? Imagine that I told you to guess a number between 1 and 100. And you guessed 50. And I'm going to just assume here the number is 83. I've just made that up. So you say, give me a number, guess a number between 0 and 100. And I say 50. And you say, no, it's higher. Well, now I've already dismissed half of the numbers in the array, because it's got to be 51 or above. So I take that, I took the original number of 100 and cut it in half. So now I take what's left and cut that in half. I say 75, and you say higher. And now in 2 guesses, I've eliminated 75% of what's in the array. So I go a half again, and I say 87, and you say lower. So now I know the number must be between 76 and 83. All right, so 76, 7, 8, 9, 80, 1, 2, 3. In 3 guesses, I've eliminated 93 possible numbers that are in there. And I keep doing that. So a binary search like that typically is done using what's called a halving type of search. It keeps cutting your thing in half. You're going to see that tomorrow. We're going to go through an example of that. And there's a lot of binary searches. All right, I just want to show you quickly the ones that you might use the most often. There's a lot of methods in here. I mean, depending on what you're working with, the find index and stuff you might use, the get length you might use. All right. There's a copy method that was in there earlier. There's not a lot in here that you're probably going to use until we get down to here. All right. There's a reverse, and you might think, well, big deal. Well, in just a second, we're going to see another method called sort, which will take a string array and sort it in alphabetic order, and it'll take a numeric array and sort it in numeric order. But if I take an array and put it in ascending order by using sort on it, then I immediately run reverse. Now I've got my array in descending order. So reverse and sort are ones you're going to use a lot if you work with numbers. All right, that's pretty much it. But I just wanted to show that to you. Again, I could have gone out here to W3 Schools, and they've got there's these arrays, and they'll have a bunch of examples as well. Array length, looping through, for each, much of the stuff we've already talked about. All right. Okay. So yeah, you got to learn how to use the array class. Here they give some of the ones, but again, I say the ones you're going to use the most are going to be binary search, sort, and reverse. We will look at each one of those tomorrow. All right. Now, there are certain methods or routines that you can use, for example, in a JavaScript array that do not exist in C# and vice versa. When you use a binary array, a binary search, it must be in ascending order. So in other words, if I'm looking through a list of 25 numbers to see if a number exists, all right, the numbers must be in ascending order. All right. I mean, it would be like if we, I know we don't even really have phone books anymore, but if we had a phone book and you were looking for somebody named Smith, you would go to the S's, then the SMs, etc. But if the names weren't in alphabetic order and you were looking for somebody named Smith, you might have to search the whole phone book. All right. So if your array is not in ascending order, you use sort on it first, then you run a binary search on it. We'll see that tomorrow. Okay. All right. When you go to copy arrays, this is kind of an important one. It used to be that when you wanted to copy an array, you had to grab the first array and put it in a loop, and one member at a time, you had to copy it from the first array to the second array. It wasn't hard, but it was kind of a pain. Now, there's an array copy method that allows you to do this. All right, so we've got different arrays here. Okay, it says where you're copying it from, where you're copying it to, and how many are you copying. All right. Now, this may sound a little bit confusing, and if it does, hey, I apologize in advance. But that said, it says an array is a reference type. What that means is if you pass an entire array from one method or function to another method or function, and in that second method or function, you change the values that are in the array, they're a permanent change. So when you think of something that's a reference type, that means that if you pass it someplace and it's changed where you pass it, it is a permanent change. All right. So they've got a few other things here too, but I'm just, again, trying to hit the highlights with you. I've said this before, I'm going to say it again, and that is, I have had people tell me in the past, Mr. Scott, I'm reselling my book. I didn't even need it all semester. You did that good a job of teaching. No, I didn't. There's a lot of stuff in this book that there's just not enough time to go through. And if you get hired as a C# developer, if that ends up being what you want to do when after taking this class or after graduating, I'd keep this book. And I'm not saying it's the best book in the world, but it's a great starting point. All right, how to code methods that work with arrays. Okay, you'll notice here, if you want to return an entire array from a routine, we've always said private decimal, but it's private decimal bracket, meaning that the method called getRateArray must return an entire array, not just a value, but an array of values. You can also, when you call an array, when you call a function or method, rather than passing in an entire array, you could pass in just one element that's in the array. If you pass in one element, it's not passed by reference. It's not, if you change it, it's not a permanent change. Rather, it's passed by copy, meaning that if you change it, you're only changing the copy. And that's what they're saying in here. All right. Again, I think at least it's going to make more sense. Maybe I'm wrong, but I don't think I am. It's going to make more sense to see this in action. I think then it'll make a lot more sense to people. So again, to return an array from a method, you need to code the brackets. To accept an array as a parameter, you need brackets. So notice, all right, if you pass an array, you're passing an array called measurements to a function or method called 2 centimeters. To show that it's an array in here, you need the brackets in there as well. All right. Says if you want to pass 2 or more arguments that haven't been grouped into an array, you can use the params keyword. I'm not going to go over that now because that probably would confuse you more than it would help you. All right. Now getting up here to page 246, how to use the null conditional operator. Probably the most confusing thing so far in this chapter. It's a relatively new development in the language. C# 6.0 is only a few years old to my knowledge. As it says, it introduced a new operator called the null conditioner operator. Now they say here, using this makes it easier to test for null values in objects like arrays. But to say something is easy is a relative term, because when you first see it, you might think that's not easy, it's hard. But it's like anything else. When you start working with it, it'll probably make more sense. In the example they give, they've got a thing called initials. All right. And it says string bracket bracket initials equals new string of size 3. All right. So not everybody has 3 initials. Some people don't have a middle name. If somebody like one of the most famous stars, I don't know, like Beyonce or somebody like that, if literally she changes her name so she has no middle name or no last name, okay. So what they're saying in here is since not everybody is going to meet this criteria, it's possible you could have nulls in some of these. And as it says down here, one way to prevent problems with a possible null reference says is to use nested if statements, but that can be confusing. So what they came up with in C# 6.0 is to use this null conditional operator. So let's look at it. All right. So it says string bracket bracket initials equal null. So imagine that you have initialized this array to null, which is legal to do. That means null again, remember, means the absence of a value. So there is no value. And then you come in and try to change the first element that's in there. There is no first element. So you get a null reference exception. All right, to try to prevent that, you can write an if statement. All right, but people thought that was too confusing, so they came up with this. And usually when you hear about conditional to prevent something like this, it'll involve question marks. All right, so the example they showed down towards the bottom there uses null conditional operators to prevent a reference exception. Now, I don't believe, now probably in your written test, in one of the written tests or the written test for chapter 8, there might be a question on this. So I'd recommend reading the stuff that's in here. You won't be tested on this in a hands-on test. There's nothing I believe that I remember that you used this for in a homework or a lab. All right. All right. More ways to refer to array elements. Let's just jump right here. So they've got an array that they're going to end up using in here. You'll notice that this array has what? It's a one-dimensional array, and it has elements 0, 1, 2, 3, 4, 5, 6, and 7. So the length is 8, and they are element 0 through element 7. All right. Now, this gets confusing. These are things that you don't have to use, but that you can use. Here, that caret means give me the second last element. All right, so from the end, I want to go 1, 2 over. If you'd have put a 1 there, it would have given you the last value. All right, I don't think I ever used that. I've ever have. You can work with ranges. This can be nice. So if I say 0 dot dot 3, that's going to be 0 through 2. If I say dot dot 3, it'll be 0 through 2 as well. All right. And again, they're giving you examples. I don't want to sit and read every one of them to you. If you say that's really confusing, then my advice would be to look at it, see if you can get at least a fundamental understanding of it, and don't use it. Again, these are all newer things. C# 8.0 is really new. All right. So that's it for just arrays. Now we're going to jump into, for the last 15 pages or so in the chapter, we're going to jump into the world of collections. All right. In the examples that I'll show you tomorrow, I believe I've got one example of an array list. All right. But I don't think I've done much work with all the other ones. Now, if you remember, one of the things I told you right near the beginning of class is that C# arrays are early binded, meaning they have to be set at compile time. What that means is they have a set size which cannot change as the program is running. With a collection, they're not fixed sized. So you can add things to a collection while the program's running. You can remove things from a collection as the program is running. So they can grow and shrink at runtime. All right. That's what differentiates a regular array in C# from a C# collection. As they refer to it here in about right here, collections are what are known as mutable, so they can change. So C# has a few common collection classes. They're shown right here. There's a list, there's a sorted list, there's a queue, and there's a stack. All right. Now, the only two that I'll go over right now that should make some sense to you, and we may have talked about this already, I don't remember. But the queue, if it's, let's assume it's the first day of class and we're not an online class, we're a regular classroom class, and we happen to be right next to the bookstore. So you come into class the first day and we get started. I take attendance and I say, hey, everybody, go to the bookstore now and get your book. All right. And let's say there's 10 of you in a class. The first person who's in line should be the first one who's waited on. The second person in line, the second one waited on, all the way through the last person in line will be the last person who's waited on. That's a queue. It's known as a FIFO structure, FIFO, which means the first one in will be the first one out. A stack, on the other hand, is the opposite of that. It's a LIFO method, last in, first out. And again, I've given this because I always thought it was probably the best, most visual representation of this. You go to a cafeteria and the cafeteria worker, there are no trays. Here comes the cafeteria worker with 100 trays, and she or he pushes them on the spring-loaded mechanism, and you go and grab a tray. Well, in that case, the last one that was in there is the first one that you grab. So that's a stack and a queue. Notice there's also a list, and as it says, it's an array list. It says it can be very efficient for accessing elements sequentially. So if you do want to go in order, but an array list can be very inefficient for inserting elements into the middle of a list. But again, the big difference is Since it's a collection, any of these four that are shown here can dynamically grow or shrink as the program is running. That's the key takeaway about this. All right, so as it says on the bottom of the page, a collection is an object that can hold one or more elements. When you start to use this, all right, you will either want to have at the top of your program where we've had using systems and using systems.windows.forms, etc. You'll probably have either using system.collections.generic or using system.collections or both, depending on what you're doing. When you use the collections.generic, that allows you to create typed collections that can only store one type of data. On the other hand, when you use system collections, they're untyped. So you can store anything, any type in the collection. And then they talk a little bit about typed versus untyped. All right. You are going to need this for some of the questions that will be asked on the written test. Also, some of the stuff that's in here, even though it may make very little sense right now, all right, are things that potentially we may end up using later on in the semester when we talk about other topics. So you'll notice in here, they've got an array list. And notice they're adding values to it. When they first created, it doesn't have necessarily a size. Then they add a first element and a second element. And then notice this will compile, but since we didn't put a type in here either, but since we put in two numbers, it thinks it's a numeric array. So when you run this, you'll get an error because it'll get to the word test and it thinks these are numbers and it finds a non-numeric value in there. All right. So that's an example of a typed, untyped collection. And here's the typed one. With the typed one, you'll notice when we do that same thing, it won't even compile. So the takeaway here is on the bottom of page 253. Typed collections have two advantages over untyped. First, they do some checking at compile time to make sure you're not doing something you shouldn't do. Whereas with an untyped collection, it does it at runtime. So you may not find out you have an error until you're running the program. All right. Secondly, as it says, it reduces the amount of casting that's needed when you retrieve things. All right. Finally, it says if you want to use untyped collections, you can edit the using directive so it refers to the system collections namespace and not the systems collection generic. It's a little more work, but it can be a little more open as far as what you can do with it. All right. Working with a list. Now, again, I love the way that they say these in these books. Now that you understand the difference between typed and untyped collections, not really, you just gave them to us. But they are going to show you some examples now of using them. All right. So we are going to end up using lists of things when we get into chapter 12 and we start talking about object-oriented programming. All right. From then on, at least potentially. It might even be a little later than chapter 12, but I can guarantee you're going to see this kind of syntax again. So when you create a list of strings or a list of decimals, etc., these are different things that you can use on them. Add is a big one. All right. Because it adds an element. It adds it to the end of the list, as it says. Clear is a big one. Contains is a big one, because it'll go through and see whether or not your list contains a specified value. All right. Add is different than insert. Add adds it to the end. Insert adds it to wherever you tell it to go. There's also a remove and a remove at. Remove removes the first one in the list. Remove at removes whatever one you tell it to remove. And there's a binary search and a sort method in here. All right. So it's mentioned here on the bottom of page 255, A list is a collection that automatically adjusts its capacity to accommodate new elements. So you can make it bigger. So if you give it a size here, as they showed, 3. So 0, 1, 2. Now it's reached its size. So it automatically doubles in size. So now there's 6. So we get 0, 1, 2, 3, 4, 5. It doubles again. Now there's 12. All right, you can specify whatever capacity to start with you want. All right. So again, if it was months, I'd probably make it 12, for example, or 13 if I wanted, they have that dummy 0 in there. And this is just more explanation of that. All right. So next, they tell you how you can retrieve things that are in a list. Okay. And again, they're setting up the list. All right. They're grabbing element 0. It's still like an array. It's the first element. It's still that. The key takeaway again is what's shown in these last two examples, or the second last example. You can remove and insert elements into a list. So in that way, all right, they are much more liberal than a regular array, which cannot change its size once it's been set. All right. There's also something, and I didn't go over this, but it was when they showed the 4 different types. We went over quickly. I gave you an example of a queue and of a stack, and we looked quickly at the array list. We didn't look at the sorted list. All right. And as it says, the sorted list exists in both typed and, and untyped types of lists. It says the examples in this figure work with a sorted list from the generic. Now, notice a sorted list is useful when you need to look up values in a list based on a key value. So this is going to work with key value pairs. This might be the first time you've seen this, but much of what happens when you work with different things in computers will center around key value pairs. All right. And when we look at it, there's the key, there's the value, there's the key, there's the value. All right. And, I've given this kind of talk before where people will say, I don't get it. Yes, you do. Because think of it like states, the 50 states that are in our union. All right. The key, for example, could be MO. The value would be Missouri. The key could be IL. The value would be Illinois, etc. All right. So as it says, when you work with this stuff, there's a key and there's a value that's associated with a key. When you work with these common properties and methods, all right, you'll notice that some of them contain a key and a value, some of them just a key, some of them just a value. So when you add something, of course, you need to give it both a key and a value. If you want to contain, notice contains key or contains value. So you want to search for something by a key. So am I searching by state abbreviation? Or am I searching by value, by state name? You can also remove a key if you don't know where it exists in the list. Or if you do know where it exists in the list, you can use a remove at and give it an index. And that would be basically, again, where it lives. So as it says here, the items in a sorted list consist of key value pairs. The items are always sorted by key value. All right. And then they give you some examples here. And again, we're probably not going to be doing very much with this, at least right now. But as an example, when you get into your 3rd semester and you take data-driven website development, we do a lot of work with something that's called JSON, JSON. and that stands for JavaScript object notation. The reason I'm telling you that is JavaScript object notation, or JSON, is all key value pairs. So you are going to see this again and again. You can use the key for any item to look up the value. All right, and the items are in a sorted list based on the keys. It says you can use the key and value properties to access the key and or the value. All right, queues and stacks I've already mentioned to you. Okay, and they use some of the more other terms. So when you NQ, that's like another person joins to the end of the line. When you DQ, that first person in line has already been waited on. And again, it's a first in, first out structure. When you work with stacks and you want to put a new tray on there, you are doing a push. All right, and that's putting a new top item in there. When you want to grab the top tray off, you're doing a pop. All right. And here's some of the stuff you can use in the queue class, and there'll be some of the stuff you can use in the stack class as well. As they mention here on the bottom of the page, they give you some distinct features that let you process them as though they were a list. And basically, that is what they are. And then the FIFO versus the LIFO. All right. Finally, the last thing that's discussed in here is working with an array list. It says, although you'll probably want to use type lists whenever possible, the last thing in here we'll talk about an array list. It says it's the most common untyped. It says the example shown here should illustrate both similarities and differences between type lists and untyped lists. It says for the most part, an array list works like a regular list. However, as it says there are a few differences. I want to quickly go over these because we're right near the end of the chapter. First, as it says, when you create an object from an array list class, you don't define the type. All right, because each element is going to be stored as a type object, which is a generic, almost an unknown type. Secondly, it says when you retrieve an element from a list, you must cast it to the appropriate type. All right. So when you put it in and you don't give it a type, sometimes that's referred to as boxing it. And when you retrieve it and you must cast and give it a type, that's known as unboxing it. So again, they show some examples of working with that in here. I'm not going to go through it any more than that. And that's it. So I'll tell you what, it is 9:47. Give me about 15 minutes here right now, and then we should be finished for the rest of the period around 10 o'clock. So first thing I want to do here, and I'm going to have to change in just a second. I'm going to have to change my share, and I will do that in just a minute. There we are. All right, hopefully what you can see on your screen right now are our exercises. Am I correct? Is that what you see?
Yeah.
Okay. Notice, since it's just chapter 8, all right, you will have two of them to do. Display a test scores array, display a test scores list. So let's quickly look at those. This should look familiar to you. We've already built something that looks like this. All right. So it says in this exercise, you'll enhance the score calculator so that it saves the scores into an array and lets the user display a list of sorted scores in a dialog box. So you put in a bunch of scores. Imagine you put in these 5 that are here in any order, and you click display scores. It's going to display all 5, but it'll sort the array. So every one of these numbers that you put in here into score, every one of those numbers goes into a scores array. All right, we still have our variables, non-array variables for score total, for score count, and for average. What's going into the array is every score we enter. All right. We will be doing one similar to that actually tomorrow. All right. Then they say here, they want you to modify it so that it stores the scores in a list as opposed to an array. All right. So it's basically, it's the same program, but in one case you're using an array, and in the other case you are using using a list. Now you might look at that and say, wait a minute, you told us that you can't change the size of the array, and that's true. So when you click display scores in here, it's assuming the array is of size 5. All right, that you're not adding and removing stuff from it. We'll get into all that stuff in just a bit. All right, finally, give me just a second here. I want to do one more share and then we'll be finished. Should have opened this beforehand, but I didn't, so let me find it. I'll bring them up in just a second. Let me change my share first. All right, so first, these are the chapter 8 labs then. This first one, I don't know if it looks hard or not, but it's really not. Okay, you write a GUI application that creates an array. The array, basically, it'll have delivery charges. Okay, so in other words, if this is your zip code, that's your delivery charge. If this is your zip code, that's your delivery charge. All right, and what you want to do then is something like this. You put in a zip code, you click calculate, and you tell it the delivery charge. All right, so if I come in there and I put in 78901, you notice there aren't any. So it really should just say delivery charge. It should say invalid zip code or unknown zip code. If I put in 63113, it's this one right here. So we get $10. It's really not a difficult program. All right. The next one, write a GUI application that calculates the cost of a resort, staying based on the number of nights. It'll make you think a little bit more. All right. So in other words, if I stay 6 nights, it would be 160 times 6 or 960. If I use the example they've got there, 4, it's 180 times 4 or 720. All right. And then finally, I like this program because it's the first time we're doing something. It's not a database, but it sort of is. All right. And what you want to be able to do, I'll give you a hint. You'll probably want to create 3 arrays. One for the names, one for the publishers, one for the prices. And after you've created those 3 arrays, then you're doing basically what's referred to as a lookup. So if I type in Call of Duty, it's going to look through the names, and if it finds Call of Duty in there any place, it'll print all that information out. So it'll print out that line. If I type in something that's not there, like Warframe, it's not in there and it's not in there. It prints out not found. It's not a difficult program, but it's one that's going to make you think. And then there's another one similar to that one that's a movie database. We'll probably end up doing one of these together as a class. All right. I don't know why Mr. Smith was so enamored with this credit card thing, but I'm not even planning on assigning that one. When we go through this tomorrow, we will go through this one more time, and I want to make sure everybody knows exactly what's going to be expected of you for the homework and the labs. All right. Let me change one last time. I'm going to have to come in one last time, change my share. and this is the other part. This program is really, really, really easy. Create a method called reverse where you can put 4 numbers in here. You click reverse. So if I put in 1, 2, 3, 4 and click reverse, this changes to 4, 3, 2, 1. It just reverses whatever you put in. All right, it's not difficult. This one's kind of a neat one. It's called sort words. So you put in a sentence, as it says there, like the quick brown fox jumps over the lazy dog, and you do a sort on it. In other words, it puts it in alphabetic order. Brown comes before dog, which comes before fox, etc. All right. This one, this bidding thing, I get confused with this. We're not doing that one. And this last one is very similar to what we're doing tomorrow. All right, we're going to do a couple of examples that are going to be the same thing. All right. So, Grant, unless you have any questions, that literally, I figured it would take around 2 hours. So that's literally what I have for today. All right. So if you're all caught up to date, that's great. Otherwise, you can start looking at the homework, labs, and written tests for Chapter 8. I will see you here tomorrow to go over some more array examples. I'll talk to you then. Thanks.
Have a good one. Bye.
You too.